Now I'd like to introduce our keynote speaker, Campbell Newman. Campbell is the Chairman of Arcana Capital. He previously held the role of Premier of Queensland from 2012 until 2015, leading an ambitious program to reform and restore the state's finances, kickstart the economy and revitalise the public service. Prior to this, Campbell served as Lord Mayor of Brisbane from 2004 to 2011 and was involved in the conception and delivery of major infrastructure projects. In 2009, he was awarded the Infrastructure Partnerships Australia Chairman's Award for Infrastructure Leadership. Before entering politics, Campbell worked for 6 years as an executive for Grainco Australia and for 4 years as a management consultant working with large Australian companies such as BHP Coal, the Hydroelectric Commission, the Australian Wheat Board and Telstra. He also spent 13 years in the Australian Army and served as an officer for the Royal Australian Engineers. Campbell holds an honours degree in civil engineering from the University of New South Wales, an MBA in financial management from UQ, and is a graduate of the Royal Military College of Duntroon. He's also a fellow of the Institute of Engineers Australia. Campbell will open our conference with his keynote address on agriculture and robotics, the next green revolution.
Well, thanks very much and good morning, ladies and gentlemen. And it's a great pleasure to be down here in Tasmania. And one of the missing bits from the CV was that I went to school here in Hobart at Friends for a couple of years in the 70s and then went to Launceston to complete my schooling. So very fond of Tasmania and have a very strong background in the state. And particularly, and I always love to tell people this, and it might explain why I'm involved in this little company, the first money I ever earned was doing irrigation shift changes on our family farm at Kindred, just south of Forth, up on the northwest coast. So I've got a passion for agriculture and I've got a passion for technology. Can I acknowledge the traditional owners this morning? Can I acknowledge the leadership team, if I can put it that way, of Australian Water Association, Francois, to Tim, who extended the invitation to me, to Jonathan and to Lindsay, and also to thank Sean for the sponsorship of the conference by GHD. Well, what I'm going to talk about very quickly this morning, and I'll talk quickly because I want to give you some time to ask some questions at the end, is about one of the world's leading agricultural technology companies. It's called Swarm Farm Robotics, and it's based in Emerald in central Queensland. So Emerald, for those who don't know the Queensland geography, probably about an hour and 20, hour and a half flying time northwest of Brisbane by turboprop aircraft. So it's right out, frankly, in the middle of nowhere, but a very vibrant agricultural and resource sector community. Big in coal mining, but then the production of all sorts of broadacre cereals, grains, also big in terms of orchards, turf farming, grapes, you name it, there's all sorts of things going on, and a cattle industry as well. So it's actually quite a good place to trial new technology in ag because there's so many parts of the ag sector. I was the chairman of this company for 2 years. I finished up around September last year, but I always like to help them out and I'm a major shareholder as well. So let's get into it. That, by the way, of course, is one of the robots, and in the background you can see some others. And as I talk this morning, think about this word swarm, because we're talking about swarms of machines working together, controlled by software, performing agricultural tasks. But firstly, to the why. Why do this? Well, the issue is feeding people, frankly, of course. So if you go back to 1958, a world population of 2.9 billion, which expanded, I'm told, from various sources on the web, to about 7.632 billion. And if you go back again, I think to the 50s, I think it was, the Club of Rome said, you know, we're going to run out of food, we can't feed people, etc. But we've been able to, and of course we're going to see, again, more billions join us over the next 10 to 20 years as well. So how did we expand food production? Well, I'm sure people in this room would have a fair idea, but it's things like the widespread use of pesticides to quell the insect attack on our crops, herbicides to put weeds at bay, the use of fertilisers, of course, manufactured, man-made fertilisers, plant breeding, getting better strains of crops, and then more recently genetically modified organisms, GMOs, although of course that's been quite controversial. We've seen a lot of land cleared, and continues to be cleared. And also it's the deployment of larger, more complex, heavy machines covering huge acreages each day per unit of labour that's been employed in that. So that's how we've done it. However, as we'll see, there's some impacts. But have a look at this. So this is a 65-metre planter operating in central Queensland. This is how agriculture is being done today. All very impressive, but that's not what we're about at Swarm Farm Robotics. Because what we've seen, ladies and gentlemen, are very significant impacts from this quest to produce more food. Okay? We've seen, and I was alluding to it before, the destruction of forest and habitat, and that can't go on. We've seen big issues with pesticide and herbicide runoff getting into natural environments, into our waterways and the like. And the older chemicals, the older ag chemicals, particularly have problems with persistence, as many of you, of course, in this room would know only too well. Then there's the issue of resistance. In the cotton industry, they were doubling, quadrupling their sort of concentrations of certain insecticides and not killing the bugs that were attacking the cotton crop. Similarly, Australia has now the dubious distinction of having one of the highest rates of herbicide-resistant weeds in the world. I think it's second only to the US. And that's because, and I digress a bit, but we've particularly in the last 20 years got into this thing called zero-till farming. The great news about zero-till farming, which is about not disturbing the soil, not ploughing, not cultivating, preserving a crust on the surface and soil moisture underneath, that allows us to get crops out when there's minimal rainfall. However, you have to use Roundup or equivalent chemicals to keep the weeds at bay. And if you don't kill the weeds, as anybody's been involved in sort of the science side of it, natural selection, you're getting these weeds ultimately becoming resistant. It's a very big issue because if we can't kill the weeds, the zero-till farming system is over. And yet it has been one of the big things for allowing Australian farmers, particularly in places like WA and central Queensland and central New South Wales, to be able to get crops out. Nutrient runoff, I've been alluding to that. Another big issue, the way we've been farming, soil erosion, and then, very interestingly, soil compaction. So you saw that massive bit of machinery, a huge tractor, and what they've done, what the farmers have done, is they've got into this thing called tram tracking, where they only run down the same lines because they actually say, okay, pragmatically, we'll create compaction there, and we'll cop that, we'll use GPS so we're always on the same spot, but they can't run these machines anywhere else. And overall, it's not good for soils. So that is another very big thing again, which affects yields. And so where do we get to with all this? The paradigm of the last 50, 60 years has to change. The yields, or the improvement in yields is plateauing. We're not seeing any more, and as I said before about zero-till, we could actually lose certain aspects of the current farming systems. So that leads to what Swarm Farm's all about. And it's all about a new way of farming using the technology to actually change the farming systems, okay? And the proponents, the people who set this up, Swarm Farm Robotics, you're going to see them in a moment in another video, a couple, husband and wife, really smart, savvy farmers based at Emerald, Andrew and Jossie Bate. and they're the architects of this whole new system. And the thing they're very fond of always saying is, look, this quote from Henry Ford, if you just ask people, the farmers, how do we farm better? They'd want bigger machines, faster machines. But that's not what we're about at Swarm Farm. So the concept that Swarm Farm have developed is pretty much encapsulated in this, in that we've had these amazing advances in technology over the last sort of 10 to 15 years, which means that you now can create this new, completely different way of producing food and fibre. And instead of those large, heavy machines you saw in the video clip, which cause damage to the soils and to the environment, rest of the environment, we see a future which is about small, lightweight, low-cost machines working together in swarms, ideally slowly and deliberately carrying out a whole range of agricultural tasks. So if you think about how you would grow a crop in your backyard or your own vegetable garden, you would prepare the garden bed, you'd till the soil, you'd make sure it was just right, you'd plant the seeds, that might be potato seeds, you would then nurture that crop, you'd clear away the weeds by hand, you'd water the crop, each potato plant, you'd give it individual attention. Well, the ultimate destination for this concept of robotic farming is getting down to individual plant attention. Now, we're not there yet, but hopefully you will see conceptually that's where we're going. So every one of the things, if you like, in the growing cycle, the planting, the control of the weeds, the control of insects, the application of fertiliser in a precise and direct way, even irrigation, which isn't there, and ultimate harvesting, that's what we're about. A machine, a platform, a system that can do all those crop growing functions.
I've been farming here for about 18 years. During that time, we've been quite progressive in our farming operations. I guess I got an inquiring mind and always thinking about what's next. And as our farming technology plateaued out, I looked around and said, you know what, everything we're doing here is limited by what we could hook on the back of a tractor or what we could tip in a spray tank. If it didn't fit into those two paradigms, it didn't happen in the paddock. If you look at what's the perfect way to grow a crop, is it actually with a large machine or is it actually with something that's quite small, that can do things slower but more accurately? And robots offered that. Our robots are a platform to carry smart technology around fields.
What stands out for us is the software developers can put a new bit of software on a robot straight away, and within an hour of completing that software package, it can be out on a robot in a field in real life conditions. We're attracting the best and brightest people in their fields, so all the different engineers, and we're actually bringing them to Emerald, getting dirt on their boots and getting them out in the field.
Our guys, they're working on their robots, they're testing their software, and they sit on the veranda of their office and critique the technology they've just built. You can write all the code you want, you can test it in simulation, you can test it in a trial, but it's not till you put it in a paddock with dust, dirt, heat, wind, birds flying in front of it, all these different things that you really test it. And then take it commercially and actually going and spraying a paddock where you really test machinery properly.
We've seen a real reduction in our chemical usage with the use of the swarms, and this is opposed to a conventional farming system with our broadacre spraying units. We were able to put them in there and pick up the weeds that would normally be missed, and the swarms have been able to target these directly and put on higher amounts of chemical at a site-specific location. Ag has been crying out for a robotic solution for a long time now, and Swarm Farm are really able to hit that market and provide that for us. We probably don't even realise what we can get out of it at the moment.
There's robotics coming out of every university, but what we're doing is actually getting our guys out of the office and into the paddocks and making the real practice change. Everyone can drive up a row and make them turn at the end of the paddock, but it's actually making those practice and incremental changes, because every paddock's different, every farm, every industry has different challenges.
A huge advantage of having a robotic mower here on the turf farm just frees up skilled staff to go and do better things for us with customers and deliveries, rather than tying up a skilled staff member on a tractor. But the key element to keep our product looking so good is the constant mowing. It is every 3 to 4 days here on the turf farm. The major comparisons we found between our normal practices and the swarm farm robot was the steadiness of an even cut. The robot would identify an obstacle and stop, whereas sometimes that doesn't happen and irrigation gets run over.
Frank Sestak, I'm Farm Development and Technical Services Manager for MSF Sugar. Grow about 600,000 tonne of cane annually across about 10,000 hectares, and we're Australia's largest cane grower. Where we see the future in robotics is being able to get our farm management more precise. Currently, some of the inefficiencies on weed control is across a large area we can't precisely target the weeds that we want to target. So we target the majority of the field for the small areas of the weeds we have in the field. But some of the environmental concerns is we are a coastal crop, which means we're also right next to the Great Barrier Reef. With more precise application, we'll be able to manage our inputs more precisely and protect our catchments better. I think there's a real desire in the industry to adopt new technology to remain sustainable in the industry, and we think that robotics will be the next big thing.
Agriculture really needs a revolution right now to do things more efficiently, to do it more sustainably, and to lift productivity for the next generation that's coming through, because there's going to be more and more demand on the resources we've got to feed populations of the world. At the moment we're doing spot spraying, we're doing blanket spraying, and we're doing turf mowing. But a bit that really excites me is our technology is a platform to deploy new technology in a paddock. Technology that doesn't work on the back of the tractor. Technology that only works when it's autonomous, when it's slow moving and extremely accurate. It's that ecosystem of new technology that goes on board a robot that's really going to be truly revolutionary in agriculture. And that's Swarm Farm's place in the world.
So what you saw there were swarms of robots working together, controlled by the software, down to centimetre accuracy with GPS correction, spot spraying based on sensors picking up the signature, the IR signature of the actual weeds in fallow paddocks. But as Andrew said, that's a platform. It can be used in sugar, it can be used in wheat production, it can be used in turf farming, it can be used in growing potatoes, it can be used in pastoral interests, looking after woody weeds, etc. It's really about a platform that we want people in the future in ag to develop their own applications for. So in terms of the benefits, there's quite a few benefits that we believe. I've got 2 slides here. Just to run through some of these, I mean, you can see them on the screen, but the first thing is higher food production, because it's precise, targeted management of the crop and the threats to the crop, the supply of nutrients and water, because these machines can be working 24/7. I mean, you set them up, they will go all day, all night. Those robots, we have the capability for those robots when they need to be refueled or replenished with replenished with herbicide, they can go back to a docking station and automatically top up and go back out and start where they'd finished off. So time doesn't matter so much anymore because these things can be deployed around the clock. It's far more efficient in terms of the undertaking of tasks. It allows more food to be produced on existing land, on the existing footprint that we already have at lower or comparable cost. It means that you can produce food on plots of land that are small and fiddly, that might have been marginal. I'm not sure if this example will work, if people don't know the geography, but if I go just west of Brisbane to a city called Toowoomba, at the edge of the Darling Downs, just on the other side of Toowoomba, they used to grow grain. They don't anymore. If you want to go to the grain country, you have to go another 50, 80 k's further west. The point is you could be growing grain there. Why don't they? Because you can't deploy the mega machinery that we saw in that earlier bit of video. So if you're thinking, Tassie, smaller farms, absolutely they can work here. It's about creating your system, working out how many robots and how those robots are sized and what tasks you deploy them on, but absolutely they work in smaller sort of holding farm sort of production operations. New farming systems and methods, I've sort of said this, it's about the imagination of farmers. They're very innovative people. Australian farmers are great farmers on the world stage. They operate with minimal protection, and we're really throwing the challenge to them to go and work out how you can use this platform, which can move around 24/7 by itself, totally autonomously. What can you bolt on the back? What sensor can you put on it? What implement can you attach to it? And how can you have these machines, again, working together? We believe it'll be safer and more sustainable. One of the biggest killers in the ag sector in Australia is the tractor, period. Tractors are dangerous. People get killed on tractors all the time. People fall asleep behind the wheels of GPS-controlled tractors now and just go off into the wild blue yonder, crashing through fences and into trees and things ultimately. So tractors are a big problem. People often say, are robots safe? Well, we actually think they're going to be a lot safer than human beings being behind the wheels of tractors. Better management of the land and environment, hopefully you can see it because we're dramatically reducing the amount of chemicals that are used. And ultimately we believe we can undertake, for example, weed control with technology like microwave zappers that will, when the machine sees a weed, it will literally stop and zap a weed, a hard to kill weed with microwave energy, or hit it with electric current or high pressure, very hot water, etc. This is big in Queensland, and we are sort of getting involved in research and trials on the Great Barrier Reef coastline of Queensland. There's also the ability to undertake tasks that are impractical or dangerous. We actually sat down with Sunwater, which is the irrigation mob in Queensland, some time ago. Now, we haven't done anything, but we had a very serious conversation about whether robots could be used to go along some of the irrigation channels, dealing with some of those aquatic weeds, because as I understand it, some very nasty and dangerous chemicals get used. And the idea was, again, to pull humans right away from that and almost, sort of protect people that way and load the chemicals with some sort of cassette that goes in, like an inkjet cartridge, or some sort of cassette gets plugged into the machine, and you never have people getting too involved with the chemicals. But going along these long irrigation channels, then spraying the chemical in a boom out into the water. Hasn't happened, but it's something we've talked about. And I think I've thrashed that final point to death. I guess there's also some social benefits, and the two entrepreneurs you saw there, Andrew and Jossie, they're rural people, they're really big on this, and they want their business to be in Emerald. They see no reason to move to Brisbane or to Sydney to develop ag tech. Maybe that sounds obvious, but they take great pride in actually trying to inspire local kids to actually consider getting into technology for this next agricultural revolution. And they want to see new high-tech jobs in those areas and people staying there. They also see a big opportunity for farmers to have a better sort of work-life balance rather than actually doing physical labour, albeit out on the paddock in a machine. They see them being able to spend more time in the office planning and thinking and strategising about how they'll better run their farms and running their businesses, which is really, really big. And finally, this race to ever larger machinery, they think that can be really pulled back because essentially we'll be moving more machines around, but they're these smaller, lightweight machines, and there's some big advantages there for the community. So basically, in summary, this is what we're about. We're about building robots that empower farmers to actually deploy new technology, to think up new ways to farm, to grow crops. And Swarm Farm Robotics I would assert this morning, you can go and check it out for yourself. It's one of the leading ag tech companies in the world, not just in Australia. Before I conclude, I'll just show you one picture. When I first moved to Tasmania as a young guy in end of 1973, Tassie then was the Apple Isle, and we all know what happened there. A lot of the orchards had to be ripped out when markets were lost. But I understand from a few discussions last night that there might be quite a few things going on in this space again. Well, I'm happy to tell you that Horticultural Innovation Australia has just basically awarded Swarm Farmer a contract to do research on using our robots in apple orchards to see how we can better grow crops there as well. So again, these machines can be deployed everywhere. So look, thank you so much for having me this morning. I hope that inspired some interest. It might sound a fair way from water, but then you're in the industry, you know the clients, you know your stakeholders, maybe the ideas that we've sparked this morning with this. So thank you very much indeed, and thanks Tim for the invitation.
Thank you. Very interesting, and I'm sure that there will be some questions for Campbell. I don't know if anyone would like to kick off. Yeah, Mr. Gardner in the front row.
Thanks, Beck. Campbell, you talked about, you just briefly mentioned irrigation. There was the irrigation channels issue, but the function of robots in irrigation, in actually distribution of water. Has there been any work done about that, around that yet? Because it would seem to me, just logistically, just trying to run my head around that, how you move water and distribute it.
Well, if you were actually doing that, if I just sort of try and think about a sort of some sort of market garden, food production type system, that'd work quite well, because at the moment these things have a payload of 450 to 600 kg or litres of water. Of agricultural chemical. It might be glyphosate or something. You can easily instead do that with water and simply then have it as an irrigation machine. I guess my point is it's because it's slow moving and it's targeted. So literally you could see the machine moving forward along the rows, identifying there's a plant and squirting right in the right location, or indeed injecting the right amount of water based on what a sensor said the soil moisture conditions were. So the point is, when you get your head around this and you think about, rather than roaring across the countryside like we saw with the big rig, it's suddenly you've got lots of these things. And what does robot mean? Maybe I should have said at the beginning, well, it comes from that Czech word meaning slave. So what we've got here now is we've got these machines that just will relentlessly keep on going, doing any task. So you can have them as mobile watering cans. Up the back there.
Well exposed, by the way. We're in the world of digitalization, all right? And that is pretty much part of the robotic digital world. What about the data gathering that these robots are doing? Are you using cloud services to gather all that data, historian, trends, see where the weeds have grown, predict where the weeds are going to grow in the future? Are you guys going to the next step in that?
That's a really good point, and it completely left out of my presentation, so I wouldn't go for too long, but there's a huge opportunity to gather data here. There are various sensors that are on the machines now, but there's also sensors that you can deploy at very little extra cost to measure all sorts of parameters like soil moisture, the weeds that are being dealt with, the soil nutrient levels, etc. So all that can be collected. In terms of how that gets handled, the big challenge, particularly in places like central Queensland, is you just don't have the network to deal with it. Some of the telcos, like Telstra, believe they're going to be able to provide a cloud interface, but the challenge there is that every single square metre of a farm needs to have coverage. Because if you don't have coverage, and we're in a technological age, and you can't gather data or you can't actually control the machines in that dead zone down there, because the Telstra tower doesn't cover it, well, that's no good to the farmer. So I'm trying to answer this question fairly briefly, but there's a lot in it. But what we envisage is that a standard farming operation will have its own mesh broadband network, So there'll be various sort of base stations that the farm will put in, so every square metre is covered. That back at the farmer's office, homestead, there'll be some sort of server and the network control for that. So stuff will immediately be collected and go in there, or the robots will be controlled from there. But then there's that uplink, that nodal point that goes into the cloud, into the internet basically, that they can get access to stuff there. So that's how we see that going. The other big issue on data, by the way, though, is the value of the data and who gets to use it. If you imagine robotic farming in 20 years' time, where there's all these machines across Australia collecting these parameters, that information I mentioned before, if that can be sourced by a commercial entity, that's great power that comes from that information about what's happening out in the paddock, in terms of trading grain or whatever. And there will be a big debate about that and how that data is used, and whether farmers give it away or sell it. And I can tell you now, most farmers are pretty smart who are in this game, and they're not going to give it away to anybody. So I could go on, but the data play is a very big part of this whole story. Down the front here? Down the front, we had one there. How many did you want to, how are you going for time?
Take these last two.
Just a quick question. Great presentation, Campbell. Has Swarm Farm looked at other technologies or robotics such as UAV and drone technologies?
Really good question as well. I think Andrew would describe himself a little bit provocatively as a drone skeptic, but I think what we see is that there'll be, again, the opportunity for an interplay between these things. So we see a farmer having, say, a drone that can go off and scan essentially the property and get the big picture, like where are the areas of poor nutrient or issues to do with soil moisture, or when it's near harvest time, what's the condition of that vast paddock, like the ones you saw in the video, where are the parts of that crop that it's now ready to start to harvest, get a map of that, and then actually start to deploy the robots to progressively act on that information. So we see the drones as data gathering things that download to that server at the homestead, and then that information being used to deploy the robots more effectively. So we see they fit together in an ecosystem in terms of cropping. There's one up here.
Lucky last, I think.
Hi. I was just wondering, and I'm sure it makes economical sense for farmers in that they've got more hours of the day to do other things, but as a rough kind of price point comparison to a rig of a similar size, what are the kind of percentage increase going this robotic swarm and the ongoing costs in terms of programming updates and things like that?
Look, at the moment it's a bit difficult to sort of give people a clear comparison there, because essentially these machines that we're building are one-offs. Basically they cost about $150,000 to build, but ultimately if they're being mass produced, they really shouldn't cost, now one of those machines that you saw there, they should cost less than, say, my wife's got a little Toyota that she uses to run around town, and it was about $18,000, $19,000. Really, there's not a lot to them. They're actually, the technology's wonderful, but there's not that much in them. So we believe that when this really gets ahead of steam, that they'll be very, very cheap. Another aspect to it, I'm not quite answering your question, but it's important. I don't know if you've heard some of these real issues coming through in farming now, where farmers are getting really cranky at the big manufacturers. I won't mention any names, but the very big ag machinery companies are creating these closed systems where you can't actually maintain the machine yourself. So you've got to, if it breaks down, you can't fix it because it's a software and mechanical issue. Whereas farmers used to be able to go and weld something up or, work on it themselves. And they're really quite cranky about this. What we're saying, and one part of our unique selling proposition, is this is an open system. You can fix this machine yourself. We do want you to be able to understand and get a young developer to say, okay, well, there's the code. Now I'm going to sort of bolt this implement on to do these things. So that's part of the thing. But ultimately, this way of doing business is a far better one economically for farmers, because it's multi-purpose. They're simple machines. If you've got a big farm, you have 24 of these things. If you've got a small farm, you only have 4 or 5. And so you can deploy your capital in small licks rather than one big machine, which is $600,000. So there's a lot in that sort of issue as well. Thank you.
Fantastic. Thank you, Campbell. I think we have a little piece of Tassie for you too.
Thank you. That's wonderful. Yeah, terrific.